Hey everybody, this is going to be your lesson that's going to cover the square root principle. It's also called the square root property. Okay, when it comes to using the square root property, we've got a lot of abstract math on the screen here. But if you look at the yellow box there, you can see that you've got a couple different formats for the square root property. And I have a lot of examples here. Sorry, I was scrolling all over the place here. But essentially, you want to get the square root problem. It's basically a quadratic, but you want to get it so that the square, or the x, is by itself. So when you solve it, you want to get x by itself. But eventually, but before you solve that, you want to get the x squared term to be all that is remaining on one side of the quadratic. Also, it's important to note that the x squared term is positive. That we know that that's the x squared term because it has the 2 there. And it also has a coefficient of 1. And there's kind of a very terrible looking way of writing it out, but you guys know what I mean. You want that coefficient to be positive 1, and if it's positive 1, you don't need to show it. And then in the other example, the other format that you guys can have for these kind of problems is where it's not necessarily just an x squared term that is by itself, but it's more like a binomial. But in and of itself, it's still a term, just like it would be if it was x squared or n squared or whatever. And but the important thing is that you want the square on one side and you want the constant on the other. So you want the non-squared term on opposite side of the constant. And for our purposes today, too, we want to make sure that the constant is positive. I'm not going to have any examples where the constant, when you solve these, the constant is negative, but that is plausible. You can have that happen. And I'm just kind of showing you here that you can get an imaginary number, but that's something that's going to be when you guys take Algebra 2. I don't think you guys do that in geometry. So let's go ahead and dive into our first example here. We have lots of examples here to go over, and you can kind of see they just kind of get a little bit different as we go along, but I think it's a good mix of problems. So our first one, you'll notice that we have x squared, and if we want to undo that, the first thing we want to do is apply the square root property to both sides. So what you do to one side, you do to the other. So you're going to take the square root of both sides. That in turn will undo the square. And then you'll notice like 81 is a nice perfect square number, but we're not always going to have nice perfect square numbers like 81. We're going to have, like on our next example, we're going to have 18. But the way this one kind of turns out, it's not very difficult. When you undo x squared with a square root, it just becomes x squared. Or not just x squared, but it just becomes x. Just a lone x. You undo the 2, the power of 2. Taking the square root is the inverse operation of a square. That's just one of those other inverse operations that we don't talk a ton about. And then x will equal, and in this case, you have to kind of keep in mind that 81 isn't just, the square root of, or the square of 9. 81, the square root of 81 is 9. But it's also the square root of negative 9. So you have to put plus or minus 9. Then I kind of show you here that negative 9 times negative 9 is indeed 81. And of course, 9 times 9 is also 81. So there's your solution. You got x equals positive 9, and you have x equals negative 9. And that's been kind of a recurring theme in our quadratic unit, that we end up getting kind of these dual solutions. And the reason for that is because the graph of a parabola, of a quadratic, is a parabola. And if it has real number solutions, it's most likely going to go through or intercept the x-axis. And so those solutions that we get for the x, another name for those are zeros, but those solutions are where that parabola goes through the x-axis. And then I'm just kind of showing you, there's some other examples here where you have a parabola where it just kind of basically touches the x-axis at one point, and then there's other parabolas where it doesn't touch the x-axis at any points. And we're going to kind of avoid those for right now. Now in this next example here, we're just going to do the same thing we did before. We're going to do the square root of both sides. When you do the square root of a square, it undoes the square. It just becomes x. And then on the other side, we want to take the square root of 18. Now 18 is not a perfect square number, so we want to kind of figure out what is the largest perfect square factor of 18. So you can kind of do a mental checklist or write them all out if you need to, but most of you probably already know that 18 is 9 times 2. And then the square root of 9 is 3. And that 3 comes out of the radical. So our answer is 3 root 2. It's actually plus or minus 3 root 2. Now when we get to example 3, you'll notice that the x squared term is not quite by itself, so we need to get rid of that 3. That's the coefficient in front of it. And if you've been alive in Algebra 1 this year, you'll notice that we can undo the 3 by dividing both sides by 3. Not just by erasing it, but by dividing both the left and the right side by 3. So I'm going to divide the left side by 3, the right side by 3, and you get x squared equals 4. Now that is not the solution. We still have to apply the square root principle to both sides, because it's not a solution until it says x equals something. X squared is not a sufficient answer. We want to know what x equals, or what n equals, or j, or whatever the letter is. So we're going to apply the square root property to both sides. So you got x squared, and then you have the square root of 4, and the square root of x squared is just x, and the square root of 4 is plus or minus 4. When we get to this example, there's a little bit more going on with the problem. You notice that the x squared term is not quite by itself, or doesn't just have a 1 attached to it. It has a 5 attached to it as a coefficient. And you'll also notice that there is a constant being added to it. So you want to get rid of that constant and bring it over to the other side. So we're going to subtract 10 from both sides. Now you don't want to divide by 5 first. You probably want to subtract 10 first. And so I'm just going to do that mentally. And 15 minus 10 is 5. And then it becomes a matter of just dividing both sides by 5. And then you have x squared, which is our objective. We want to get x squared to be the only thing that's left on one side so that we can apply that square root principle to both sides. So we've got x squared equals 5 divided by 5 is, let me use my calculator here. Oh, it's 1. So now you're going to do the square root property to both sides. And you're going to apply the square root to the left side and to the right side. And then you get x equals plus or minus 1. Now in the next example here, this is our first one where we don't just have a x squared term. We have actually a binomial that's being squared, x minus 3. It's an expression. X minus 3 is being squared, but the 2 is outside the parentheses. So you can just do a simple undoing of that by applying the square root principle to, yes, you guessed it, both sides. So we're going to take the square root of the left side and we're going to do the square root of the right side. And in turn, when we do the square root of x minus 3 on all of that squared, it just becomes x minus 3. You just have to get rid of that 2. You don't really need the parentheses around it either. So you just write x minus 3. And then x minus 3 equals plus or minus 6. The square root of 36 is positive 6 and negative 6. And then you're going to want to add 3 to both sides. And here's where you want to be just a little bit careful, because the 6 is not just 6. It's plus or minus 6. So it might be to your benefit to kind of just write it out, just so you can see it. But 6 plus 3, positive 6 plus 3. And then write out another equation. It's just a really simple equation, but the negative 6 solution, where you have negative 6 plus 3. Now, notice it's not negative 6 minus 3. The 3 was positive both times, but now they're really super simple. X equals 9, and on the other one, x equals negative 3. And there are your 2 solutions. So if you're to graph those on a parabola, those would be your zeros. That's where it would intercept the x-axis. So on the next example here, I'm going to kind of just follow the same motions that we have been following, which is I'm going to apply the square root to both sides. That, as you would guess, undoes the square. So it just becomes x plus 7. No more square on that side. It's not to the second power. And then the square root of 4 is plus or minus 2. Then you're going to subtract 7 from both sides. And I'm going to do what I did last time and just kind of break it up, split it up, and just so I can see the 2 different solutions. So it's going to be negative 7 plus 2. So you want to apply the positive 2 value to that. And then you're going to do another equation where it's going to be negative 7 minus 2. And those aren't really too difficult to figure out. Those are x equals -5, and then you got x equals -9. Now the second to last example here, very much like the last one, except when we square both sides, we're not going to get a nice perfect square. So you're going to apply the square root to both sides. You get x plus 4 without the 2, without the squared. It just becomes x plus 4. And then on the right side, you cannot simplify square root of 11, and it's not a perfect square number, and nor does it have any perfect square factors. So you just have to write plus or minus the square root of 11, because there's nothing we can do to 11, and I would avoid putting it in your calculator because you're just going to get an irrational number no matter how you put it in there. So just put 11. And then it becomes a matter of just kind of subtracting 4 from both sides. And you want to be careful with this one. You cannot, those are definitely not like terms. So you can't add or subtract 4 from square root of 11 or the negative square root of 11. So you just kind of have to just put it all together. So your answers are going to be x equals -4 plus or minus root 11. And that's an acceptable way to write your answer. I mean, if you want to break it up and write it into 2 different solutions, that's fine too, but you can just write -4 plus root 11, and then your other solution is going to be x equals -4 minus root 11. Now, when you get to the next example here, if you want to pause the video and just try this out on your own and see how your answer matches up with mine, that's fine. Go ahead, and I'll wait. Well, I'm not going to wait. You can just pause it. So if you unpause it, I'm just going to go ahead and explain this. I want to get rid of that 4. That's essentially the coefficient of that x plus 3 term that's squared. So we're going to do that by dividing. So divide both sides by 4. So the left side just becomes x plus 3 squared. The squared is still there. All we undid first was the 4. And then on the right side it became, on the right side it became 6. And now you can just take the square root of both sides. Now remember, the purpose of doing the square root of both sides is that it undoes the square. That 2 goes away. So now it becomes x plus 3 equals, and then you're probably going to recognize at this point that 6 cannot be, or the square root of 6 cannot be factored at all. So we're just going to write it as plus or minus root 6. And then it just becomes a matter of just bringing over the -3 or the -3, because you're going to do the opposite of plus 3. And there's our solution. X equals -3 plus or minus root 6. And just like we've been doing on a lot of the other ones, if you want to break that up into 2 different solutions, go ahead, do that. But you don't have to. Okay, so that does it for this video. I hope everybody hasn't been too confused by this and kind of gets this. This is my first video lesson for you guys, and hopefully it wasn't too terrible. And on top of that too, I hope everyone's doing well and staying safe and staying healthy. And this is definitely kind of a crazy, weird time in history. So hopefully we'll see each other back at school again someday. I'm not sure when, but it'd be good to see everybody again. And that's it. Everyone have a great day. See ya.